All right, chemistry. This is mostly for Cohort B who won't get the session, the Zoom session until tomorrow. So hopefully this gets you enough information to start the lab and you're going to try your best. We're also going to go through a lot of the lab together in class. So don't worry if you can't do it all asynchronously. We'll do it together tomorrow, which would be Thursday. So, but you should watch this in advance, have everything ready to go, maybe come with some questions, and we'll talk about it when we're on Zoom. So here is some ionic compounds. I have sodium sulfide and iron 2 chloride. And for the lab, we're going to be dissolving these in water. So the way chemists show that they're taking these salts, they're ionic compounds, and dissolving them in water, is we use this little abbreviation AQ. Now I'm just squeezing it in up above, but AQ stands for aqueous. So in the lab video, you're going to see me mixing two solutions. They're aqueous solutions. The salts or the ionic compounds have been dissolved in water. Okay. So what we need to do is think through the formulas on these two solutions. And so sodium sulfide, you guys can see I have my ion sheet listed over here on the side. Sodium, a metal, has a +1 charge, and sulfide is down here. It has a -2 charge. So if I write these out, sodium and sulfide, turns out I would need 2 sodium ions to balance the charge of the sulfide, right? So Na2S, and I write a little AQ below or beside it to show that I've dissolved it in water, plus iron 2 chloride. So iron 2, we know from our Roman numerals, iron can have multiple oxidation states, so we show that 2 to designate that it's lost 2 electrons. And then chloride, I can come look up. Chloride's down in the -1 charge group. It's in group 7. So then, same thing here. I would need 2 chlorides to balance the charge. So this would end up being FeCl2, aqueous. And I'm going to cut and paste these so that, or move them over so that it lines up here. Let me zoom out a little. Okay, when we combine two aqueous solutions, sometimes we get what's called a precipitate. Okay, and a precipitate is a solid salt that forms when two soluble solutions are put together. And so when I add in the videos my drops of I think it was copper, what was it? Copper chloride, you'll see a blue substance form. Okay, that's a precipitate. Okay, so here we can go through and we can write out what the precipitate is, and we show that a chemical reaction is going to occur by designating it with an arrow. And what we do is we mix up, or we do what's called a double replacement reaction, where we take the cation from one species, and since we're mixing the solutions together or dropping the solution together, it's going to have the chance to form an ionic compound with the anion from the other solution. So here, sodium and chloride might find each other in solution and mix. And they'll mix in a 1-to-1 ratio since it's got a plus and a minus charge. So I end up with NaCl. We know from experience that sodium chloride, just table salt is soluble in water. So I'm going to also list it as AQ. But the other product, when the iron 2 combines with the sulfides, so in this case, iron 2 and S2 minus are going to form iron sulfide. So let me throw that in here, plus, and they're also going to combine in a 1-to-1 ratio because their charges are opposite. This forms a solid. Now, this solid is called a precipitate, and usually instead of writing the whole word, we're just going to put a S next to it. And I'm going to note that this is a precipitate. So you're going to see a chunky solid. Now I've got a video of this. You're going to notice the person on YouTube doing a precipitation reaction. He's using different reactants than I started with but it's going to be a very similar reaction, and we're gonna write and go through the chemical formulas involved there. Some of you might be yelling at me right now and saying, Mr. Ford, this is not a balanced chemical reaction. You know, I remember in physical science, you guys harped on that. To make you guys a little happier right now, let me do this, and that'll balance it. Okay, but we're going to talk about balancing reactions later. So without that red 2, that's kind of where we're at right now in terms of being in Unit 3. And we'll talk about balancing reactions and types of reactions later. Okay, but here's the YouTube video. Let me switch to it. You're going to see a precipitate form here. Let's see if I can make this bigger. And you can, let's get to a different one. Let's see if I can find the one I wanted. I think it's this one. Yeah, here we go. Back up. All right. So you can see he's got a solution of silver nitrate, and he's dropping in something called potassium chromate. So silver nitrate and potassium chromate. I'm going to write those out and wait for my pen to reconnect. Silver nitrate and potassium chromate contain something called polyatomic ions. And polyatomic ions are new. We're going to talk about them a lot on the Zoom meeting. So you guys have to be patient with me. I know I'm throwing a lot at you, but we're going to have another week to practice them. So silver nitrate and potassium chromate. Oh, and I should throw in that they're aqueous because he had them both in solutions. He had the silver nitrate was the clear solution sitting in the beaker, and the potassium chromate was what he had in his dropper. And then when they combined, they formed a precipitate. We can predict what that precipitate is. Now you may notice, and I got to point this out, the endings of these names are not ides. And in the first example, sodium sulfide and iron chloride, you guys will look at this list and you'll look down at your ions and you're going to see lots of ides: hydride, fluoride, chloride, bromide, iodide, oxide, sulfide. Those are all single element ions. Okay, they're all ions made out of one element. Well, it turns out there's a whole nother class of species, chemicals. Okay, they're more ions, but they contain more than one element. And so I've got them down here. They're called polyatomic ions. And here's some common anions. So you guys will notice quickly that some of them end in ide, some of them end in ite, some of them end in ate. Okay, but they're not just all ides. So a lot of time ides are indicative of binary compounds made of just simple elements, or usually the anions have one element and they combine with a cation. Well, these polyatomic ions are made of more than one element. So for example, carbonate is made of carbon and oxygen. It's actually made of one carbon atom and 3 oxygen atoms. Or nitrite is made of one nitrogen and 2 oxygen atoms. Okay, these ions still do have charges. So carbonate has a 2 negative charge. Nitrite has a 1 minus charge. Let's see if we've got a different one. Arsenate, right? Arsenate has a 3 minus charge. And so what these are groups of atoms that find some stability and satisfy their electron orbitals by grouping together in little clusters of atoms. So let's go look at that chemical reaction here. So silver nitrate, you can look up on your chart, your common ion chart, you can easily find silver. Silver has 1 oxidation state, so just positive. Okay, nitrate, you have to look on your polyatomic ion sheet. Nitrate is made of 1 nitrogen and 3 oxygen atoms, so I could kind of draw this. Maybe this is the nitrogen atom in the middle, 3 oxygen atoms off of it, and together this whole thing has an additional electron in its orbitals, okay, and that gives it a negative charge. So think of nitrate as just a collection of atoms. We think of it as one thing, and it has one additional electron that gives it a negative charge. That's what the minus sign up top means. So when we write the chemical formula for silver nitrate, we still balance the charge. Okay, I need one silver and one nitrate. So a plus charge and a minus charge balance together to make a neutral ionic compound. Then I get silver nitrate. And we're going to do the same for potassium chromate. So potassium, I look up, it's a group 1 element. So it has a plus charge. Chromate, I'm going to go refer to my polyatomic ions and look for chromate. So it's CrO4 2 minus, CrO4. So those are the atoms involved, right? 1 chromium, 4 oxygens. Collectively, that ion, CrO4, has a 2 minus charge. So this one would look like maybe a chromium in the middle, 4 oxygen atoms bound to it, and all together collectively, they have 2 extra electrons in their orbitals. And so when they combine, we need 2 potassiums, 2 pluses, to balance out the negative 2 charge. So potassium chromate would look something like this. Okay, and I'll put aqueous. So still we're balancing pluses and minuses. When these combine, we get some different things happening. The silver can partner up with the chromate, okay, and so we form Ag, and I need 2 Ags because it's got a positive charge to balance out a chromate. That turns out to be that brown precipitate that you saw. So let me flip back. So that brown solid stuff that you see, that is silver chromate. And then the nitrate partners up with the potassium. That's a +1 charge and a -1 charge. So I get +1, -1. Potassium nitrate. And this is just my knowledge. It's soluble in water, so I write AQ. So here the precipitate we show it as a solid, okay, with an S. And so that's how we deal with polyatomic ions. So this is new, and we're going to talk more about it tomorrow. So let me pull up the lab for you. Oops. And let me just look at the, oh, actually, I should do it from my docs. If you're looking at the pre-lab questions, let me just do one for you, and maybe you could try the other. So please, even if you can't do the pre-lab questions, please read the introduction and background. It talks more about polyatomic ions. And read the experiment overview. Okay, and here's where we'll start. Many common drugstore chemicals are ionic compounds. Write the correct empirical formula, okay, for each of the following compounds. So milk of magnesia is known as magnesium hydroxide. And so for magnesium hydroxide, this is what we'll spend a lot of time practicing, is you're going to look up these ions. So magnesium is just a cation made out of magnesium. It's lost 2 electrons. Again, you don't have to memorize them. Just go look them up. There's magnesium. Hydroxide, though. Hydroxide, you're going to look at this top list, and you're like, okay, it ends in "ide," but I can find hydride, but I can't find hydroxide. So then you go down to your polyatomic ions, and it's there listed. It's an oxygen and a hydrogen atom combined with an extra electron for a charge of -1. So you need to write down OH negative. And now you're like, how do I balance it? Well, hydroxide, since its charge is -1, I'm going to need 2 of them. And the way we write this formula, when we combine all of those ions, we have a single magnesium and we have two hydroxides. Now, the way we show two hydroxides is we put parentheses around the polyatomic ion. So if you have more than one polyatomic ion, you use parentheses to designate, right, that there's two of the whole thing. So the whole thing is an OH, and we have two of them with the magnesium. So that's a 1-to-2 ratio. Do one more. Let's look at sodium carbonate. So sodium is in group 1. It likes to lose one electron, Na+. And carbonate, right? You're like, oh, it doesn't end in ide. So I'm going to jump directly to my polyatomic anions. And there it is, CO3, 2-. Okay, so I balance the charge. This time I need 2 sodiums to balance out the charge of -2. Again, I'm balancing charges. So these numbers in the upper right-hand corner need to add up to 0. So together, this is NaCO3. Now, I don't need parentheses around the carbonate because I only have one of them. There is a hidden set of parentheses with a hidden one around the carbonate, but because there's a single one, we just have chosen to leave it off. Just like here, there's one magnesium, but we don't write a 1, we just leave it alone. Oops, and I needed a 2, sorry. I think I erased something. Na2CO3. So Na2CO3 is sodium carbonate. Okay. So hopefully that gets you going. Again, try your best. Read through the instructions, watch my videos, be ready to complete this. We'll talk about it in class, and we're going to do lots of this polyatomic naming and formula writing tomorrow. So good luck. Thanks. Sorry for please bear with me. I know I'm throwing a lot at you. So I know you guys can do this, and I will talk to you tomorrow.